Hello, thanks for joining me today. We're going to talk about proportions, and we've been talking about rates, and a proportion is just two rates compared to each other or said to be equal. So if two ratios are in proportion, then the two ratios are equal. They're equal to each other, which means that they could be reduced. One could be reduced to the other, or they can both be reduced to a third um, rate and ratio in the lowest form. So let me give you an example here. This first one raisin is to 5 cornflakes as 8 raisins is to 40 cornflakes. So we're comparing raisins to cornflakes. The first half of the sentence says we have 1 raisin to 5 cornflakes. And then as this is saying that it's equal to 8 raisins. I didn't know how to spell the word raisins before this. To 40 cornflakes. Now, is this really true? Well, first of all, this first question just says write it as proportion, and so we did it. There it is. That's the proportion. That's what it means. This ratio is equal to that ratio. But is it true? Is it true that 8 to 40 is equal to 1 to 5? And if we think about reducing the fraction 8 over 40, we would divide by 8 on top and we would divide by 8 on the bottom. And we would indeed get 1 on top and 5 on the bottom. So yes, they are equal. Okay, so the word proportion means that the two ratios are equal. It's not a question, like we're going to ask the question in a little bit, is this really a proportion or are they in proportion? But that means are they equal? Let's do this next one because this one confuses us. 1.5 cups of milk is to 10 bagels. There's our first. As 3/4 cup of milk is to 5 bagels. So there's our two ratios. 1.5 milk to 10 bagels equals 3/4 milk to 5 bagels. Now, again, this question did not ask us to evaluate whether this was true or not, but we can. And I find that it's easier to make these evaluations without all the words. So I'm just going to write 1.5 over 10 equals 3/4 over 5. Now, here is the big secret. Proportions can be evaluated by taking each fraction and simplifying it. So taking this fraction and simplifying it into simplest terms. So I can do that with 1.5 to 10. Let's see, 1 times 2 is 2. So 2 halves plus 1/2 is 3 halves. So this is 3 halves to 10 equals 3/4 to 5. When I divide by 10, it's the same as multiplying by 1/10. So I can say, well, this is 3 halves times 1/10 equals 3/4 times 1/5. And 3 times 1 is 3, and 2 times 10 is 20. 3 times 1 is 3, and 4 times 5 is 20. And so yes, the two fractions are in reduced, simplified form are equal to each other. So that is one way that we can test ratios to see if they're equal. But it turns out that there is a much, much, much easier way, and it's called cross multiplying, and this is everybody's favorite thing. Cross multiplying is the way that you test ratios or solve ratios. We'll do both today. We take sometimes people call this cross products. we take the numerator of one ratio and the denominator of the other ratio, multiply them together, and then do the other way, the other denominator times the other numerator, and set those equal to each other. So this would be 1 1/2 times 5 is equal to 10 times 3/4. Well, let's see, 1 1/2 times 5, it's easier to turn that into a mixed number, so 1 1/2 is 3/2 times 5, and then 10 times 3/4. And 5 times 3/2, we just turn 5 into a fraction, it's 5 over 1, 3 times 5 is 15, over 2 times 1 is 2. And then same with the 10, put it over 1, 10 times 3 is 30, and 1 times 4 is 4. And 15/2 does equal 34, so I know because if I reduce 34, divide by 2, top and bottom, I would get 15/2, so that is true. Okay, proportions are two ratios that are equal fractions. They're equal to each other. Now, since that is true, that's what a proportion is, then to tell if a proportion is true or false, we just need to ask, are these ratios equal to each other? And we can ask that question in, again, different ways. We could say, can these two fractions be reduced to the same fraction, reduced to the lowest form is the same fraction? And that one causes us to kind of have to be clever and think about things, and reducing fractions and whatnot. But the easiest way to tell is just to take the cross products and compare them. So is 7 times 7 equal to 4 times 12? And 7 times 7 is 49, and 4 times 12 is 48. Not equal, so false. These fractions are very close to being equal, but they are not equal because their cross products are not equal. Let's do that again with the second one. 8/24 equals 3/9. Let's take the cross products. 3 times 24 equals 8 times 9. Well, 3 times 24 is 72, and 8 times 9 is also 72, so true. The second proportion is true. The first proportion was false. Now let's do it again with the third one, and this time we have fractions in the numerators and the denominators. Can we multiply those together? Sure we can. This is 2/7 times 1/10 is equal to, or implies, 2/5 times 1/3. Okay, let's see if these are equal. So 2 times 1 is 2, 7 times 10 is 70, 2 times 1 is 2, 5 times 3 is 15. Oh dear, not anywhere close to being true. So this is false. And you can see that once we take the cross products, it's really easy to evaluate whether these are true or false. Now, being able to verify that two ratios are in proportion is a great skill to have. Knowing what a proportion is wonderful. But the big thing that we do with ratios, proportions, is solve them. So for the rest of the time, we are going to be solving proportions. And what we mean by that is, if I know that these fractions are supposed to be in proportion, what is the value in this unknown spot, in the x spot, that will make this proportion true? What will make that true? And we're going to solve just the way we've been doing, just like we've been comparing proportions, or ratios, by cross multiplication. We're going to cross multiply. 18 times x is 18x equals 3 times 54. And then we will solve that equation. Now, I like to, let me just show you, there's two ways to do this. We could get our calculator out, and I'm going to pull up my calculator. I'm going to say, what's 3 times 54? 3 times 54 equals 162. And then I'll just divide by 18. Equals 9. Okay. So this is 162, 18x, 162, and then I'm going to divide by 18, and x equals 9. Okay, now, as long as you're using a calculator, and that's fine, it's fine to use a calculator in this situation. That would be how I would do it. Here's how I would do it if I don't have a calculator, if I want to be clever, or I want to do it without taking the trouble to pull out my calculator. I would say, well, let's see, 18 times x equals 3 times 54, and then I'm going to divide by 18, and x equals 3 times 54 divided by 18. Well, let's think about that. 54, well, 54 is 2 times something. What is it? 2 times 27, which is 3 times 9. And 18 is 2 times 9. And so now I notice that there is a 2 in the top and the bottom. There's a 9 on the top and the bottom. And if I cross those out, I'm left with just a 3 and another 3. So x is equal to, on top, 3 times 3, which is 9. And on the bottom, everything's been canceled out, so we're just left with a 1. So 9 over 1, which is 9. Okay, so it's always a good idea when you're dealing with fractions to be comfortable reducing them by first factoring them. That really helps out. Okay, there we go. That's solving proportions, easy peasy. Let's do two more examples, one with fractions and mixed numbers in our numerators and denominators of our proportions, of our ratios, and then one with decimals. And you guessed it, we're going to do the same method every single time. We're just going to take the cross products. So 11 fourths times y equals 7 3/5 times 25 eighths. Now notice that two of these fractions are in improper fraction form, and one of them is in mixed number form. Probably would be a good idea to get them all into mixed number form, so I'm going to multiply 7 times 5, that's 35 fifths, plus 3 fifths is 38 fifths. So 38 fifths times 25 eighths. And then when I solve for y, I'm going to divide by 11 fourths, or I'm going to multiply both sides by the reciprocal of 11 fourths, which is 4 elevenths. So that means that y equals 38 fifths times 25 eighths times 4 elevenths. Now, this is where that factoring idea comes in really handy, because you can imagine it would be a pain in the neck to do 38 times 25 times 4, and then 5 times 8 times 11, and then reducing that fraction with those huge numbers in the numerator and the denominator. So super, super valuable to say, let's break this down. 25 is 5 times 5, and 38 is 2 times 19. And so now I have, and 8 is 2 times 4. So now I see some things that I can cancel. I've got the 4 in the numerator and the denominator. I've got a 2 in the numerator and the denominator. I've got a 5 there in the numerator and the denominator. And in the numerator, I'm left with 19 times 5, and the denominator, I'm left with 11. So I'm just going to write 19 times 5. Let's see, that's 95, I think, and 11. And so that's what y equals, 95 elevenths. and that will be my answer. I could divide that on the calculator and get the decimal representation, but I would not want to do that because that's not going to come out evenly. It's going to be some decimal number that may be repeating, and maybe it's not, but maybe it's really long. So this is the most simple representation of the answer, and it makes perfect sense that it is a improper fraction, just like all the other fractions were. So we're perfectly happy with that answer. Let's do the last one. Same process. We're going to cross multiply. 2.5n times n equals, let's see, 1.8 times 8.4. And then I'm going to divide by 2.5 on both sides. Now here, I've done that so that I can just type it on my calculator. There's really no sense in doing this longhand. We could try, but it would be a lot easier to do it on the calculator. So let's see, we have 1.8 times 8.4 divided by 2.5 equals, and I get 6.048. Now you may be asking yourself, well, why did we give the answer in fractions on the last question, and we're just throwing all that away and doing decimals on this final question? Well, partly the reason has to do with the way the question was presented. In that purple question there, it was presented to me in fraction form, and so I want my answer to be in fraction form. This last one that I did in red, the question was given to me with decimals, and so I am happy or I'm content to give my answer in decimals. All right, well, thank you so much for watching. This is tricky stuff, but it is so worth practicing. You will be glad you did many times in your math career in algebra and geometry and beyond. So enjoy. Thank you for watching.